Good evening, ladies and gentlemen. I'm out here from Comox, British Columbia, where sometimes it freezes, but hardly ever. And Danny told me to talk about the power of truth. I've never known anything else, to tell you the truth. They nicknamed me Dr. Truth in Greenpeace because I didn't let them lie whenever I had the opportunity to stop them. But then I had to leave because they wouldn't let me do that anymore. Anyways, there's Galileo Galilei there. This climate change thing is the worst thing that's happened to science and the Enlightenment since Galileo. You could mark a lot of different places for where the Enlightenment started, but he was certainly part of it. And of course, he said that the Earth revolved around the sun rather than the opposite, which had been the general consensus among 97% of the general public until that time, which proves that the 97% are always right, doesn't it? And even if it is a fake 97%. And the church, it was, I believe, sentenced him to death, or at least said they were going to sentence him to death unless he recanted, which he did, and then they sentenced him to house arrest for the rest of his life as a result of telling the truth. And so that's what truth can get you into a lot of trouble, and the same thing is true today with this climate issue. A lot of people have got into a lot of trouble with this truth. My friend Bob Carter from the University in Queensland in Australia, I think he died of a broken heart because he had a massive heart attack not long after he was censored and fired by his university for daring to speak the skeptic line on climate. And now Peter Ridd, expert on coral reefs, has been essentially fired from his position at the same university for saying that the Great Barrier Reef is not dying. And he is telling the truth. And all the parasites who are collecting all this money, now I think they're giving $500 million to the academe and scientists in Australia to save the reef. How do you save the reef? By going out and looking at it and taking photographs of it and measuring things. How does that save the reef? They're not being given that money to stop CO2 from going into the atmosphere, although it's a lie that that's the cause of anything wrong with the coral reef. The fact of the matter is the coral reef's just fine. But as you'll see, there's a reason why they use the coral reef and other such things that nobody can see very easily to make up stories about what's happening in this world. I'm going to tell you a little bit about where I come from. There it is there. I grew up in that house on that float camp on the northwest tip of Vancouver Island in the rainforest there, right next to the Pacific Ocean, which is just over the tops of those mountains in the background. So it's only about 5 or 10 minutes out there and you're in the briny deep. And there was no road to my village. My father owned that village and had 60 people living there, working on the shoreline cutting trees. And there was no road to our village, so the road didn't come till I was about 16, I guess. And everybody was happy because now this place would grow. Half the people use the road to get out. So we learned something about human nature there that day. But you can sort of see why, but I loved it there because I was a child growing up in this idyllic wilderness, and when the tide was out, there was big tide flats there that you could walk on in the sunshine or the rain, whatever it may be, and then you could be in the forest, or, you know, it was really beautiful. Still is, and I have a home there to this day that my wife and I built 45 years ago when we met. And it's a fantastic spot. So if ever you get a chance to go to Winter Harbor, actually I've met 2 people here who've been to Winter Harbor in their lifetime, and there's one, and there's another, and there's another. So 3. It's a place that a lot of people have been because of the sports fishing there. It's well known for that. But I was sent off to boarding school in Vancouver at age 14 after going to school by boat from that little float camp for 8 years. And I soon found myself at the University of British Columbia. I had excelled in the life sciences, biology, biochemistry, genetics, a little bit of forestry, because that was my family's business and the biggest industry in British Columbia, and also a life science. And in the mid-60s, I discovered the science of ecology, a word which had not yet appeared in the public print and which people did not know. But it goes back for quite a while, about 100 years or so at that time, to the 1860s. The study of soil science on the steppes of the Ukraine is the origin of ecology, the study of all the factors that go together to make the ecosystem and the soil. It just blew my mind that you could actually have a science that would bring together everything in the whole earth into one concept of all being interrelated. And it kind of gave me a way of seeing that science also had a spiritual dimension in the infinity of the interrelationships and the chaos that comes out of the earth to make the order of life and all of that. So I got turned on, and I became a hippie, of course, in the time of that time. And I joined a group in a church basement to plan a voyage against U.S. hydrogen bomb testing. Of course, we decided to take on the world's most powerful organization, which was the U.S. Atomic Energy Commission, and to sail against the hydrogen bomb testing as a symbol of our opposition to the threat of all-out nuclear war, as right then was the height of the Cold War, the Vietnam War, and the threat of all-out nuclear war, the very peak of the Cold War in the early 1970s. And we didn't really want this to happen to all the cities in the world. And so we sailed on that voyage, and amazingly, a ragtag-looking bunch of what appeared to be hippies, and we were kind of in the hippie era, but every single one of those people was professional in one way or another, writers and scientists and engineers and doctors and lawyers. And we sailed, and that was the last hydrogen bomb the United States ever tested. President Nixon canceled the remaining tests in the series due to overwhelming opposition in the United States and Canada, which we had kind of spearheaded in a way because we became a symbol on our boat sailing towards the tests. And it worked as a media image, as what we called a mind bomb in those days, which today we call going viral. And we went viral as a result of getting up and actually doing something instead of just sitting in our chairs reading and complaining. So on our way back from Amchitka in the Aleutians, we were welcomed into the big house of the Namgis Nation at Alert Bay, near my northern Vancouver Island home, where they made us brothers of the tribe. There we learned the legend of the warriors of the rainbow. It's after a Cree legend that says one day when the skies are black and the birds fall dead and the waters are poisoned, that people around the world will join together to save the earth. We named our ship the Rainbow Warrior, and I spent the next 15 years full-time on the front lines of the movement around the world in the top committee of Greenpeace. Next, we took on French atmospheric nuclear testing in the South Pacific. France was still detonating atomic and hydrogen bombs in the air in the early 70s, sending radiation around the southern hemisphere. They were a little more difficult. But because of our intervention in the Stockholm Environment Conference, the first UN conference on the environment, in 1972, we lobbied all the Pacific countries and got New Zealand to put a motion on the floor to condemn atmospheric nuclear testing in that international forum, which overwhelmingly passed, much to the chagrin of the French, and led eventually to them agreeing to stop testing in the atmosphere and go underground and drilling into the coral reef down deep to set off their atomic weapons. And that continued till long after I left Greenpeace. It wasn't till the mid-90s that nuclear testing ended in the South Pacific and most other places as well. Yeah, but as late as 1985, with that nuclear testing still going on and we still protesting against it every year, French commandos bombed and sank the Rainbow Warrior in Auckland Harbor, killing our photographer. This caused a huge commotion around the world. It was the first act of terrorism in New Zealand, and it was the most famous incident in the history of Greenpeace to this day. It wasn't long after that I left. But let's go back for a little more history, back 10 years to 1975, the first confrontation with the Soviet factory whaling fleet in the North Pacific. I'm driving my friend Fred, the cameraman, into the Soviet fleet off California, out of sight of land, and we approached the whaling fleet You can see the dead whales tied to the side of the harpoon boat there. They're going to go up that hole in the back of the factory ship to be cut up on deck. They were killing 30,000 whales a year at this time in the North Pacific, the Japanese and Russians combined. But we put ourselves in front of the harpoons in our little boats to protect the fleeing whales and got on television around the world, bringing the Save the Whales movement into everyone's living room for the first time. This resulted 4 years later in the total cessation of factory whaling in the world's oceans. And today there's only a pittance. It's too bad the Japanese still think it's important to go and kill 500 whales in Antarctica every year. They're going back again this year, apparently. But it is nothing, and certainly is not an endangerment to the survival of whales like the 30,000 a year slaughter was. I wish someone would stop it still. Here I am sitting on a baby seal off the east coast of Canada to save it from the Hunters Club, where they were wading into the nursing colony of a wild marine mammal and bludgeoning hundreds of thousands of babies to death in front of their mothers. And so the seal was clubbed and skinned, and I was hauled off to jail. But this picture appeared in over 3,000 newspapers around the world the next morning. This and many other direct actions brought some necessary changes to the way in which Canada manages its East Coast seal herds. Anyways, why would I leave Greenpeace after all that, after 15 years? Well, there were sort of two reasons. First was the high-level reason. When we started in Greenpeace, we had a very strong humanitarian orientation. That's the piece in Greenpeace, to save the world from all-out nuclear war. And we had a role in that. As time went on and we focused more on nature issues, whales, seals, and then toxic waste, which is a bad thing people were doing, Greenpeace and the rest of the movement drifted into this idea that humans were the enemies of nature, the enemies of the earth. And sort of at a high philosophical level, I know that ecology is about we're all one. Humans are not the enemies of the earth. We are part of evolution. We came from the earth like all the rest of the creatures on this planet. And we are all interrelated. We're not like the only evil species, which is kind of how it was characterized. And for me, it's just way too much like original sin, the idea that humans have original sin and everything else is good. And so, no, because I grew up in an agnostic household, to put it mildly, and I've never been an institutionalized religious person. I have, as I mentioned earlier, I have a strong spiritual side to me, mostly in terms of the here and now, the nature and this beautiful green and blue planet that we live on. But I just couldn't continue to belong to an organization that thought humans were the enemies of nature. And then the sharp end of the stick, the pointy end, was that my fellow international directors in 1985, none of whom had any formal science education, just by coincidence, except for me, and they decided that seeing as though chlorine was part of dioxin, DDT, and PCBs, to name a few chlorinated hydrocarbons, they decided that chlorine was the common denominator of these toxics and should therefore be banned worldwide. So the Ban Chlorine Worldwide campaign was launched. Meanwhile, me in the International Council trying to explain to these people, you guys, this is one of the elements in the periodic table. It is one of the building blocks of the universe. 11% of the Earth's crust consists of chlorine. Sorry, it's the 11th most common element in the Earth's crust. And most importantly, it is the most important element of all the elements for public health. Adding chlorine to drinking water and putting it in spas and swimming pools is the biggest advance in the history of public health, and about 85% of our synthetic pharmaceuticals, medicines, are made with chlorine chemistry. Just look at the ingredients on your cold and flu medicines even, and you will see a little Cl after many of them. Well, the Greenpeace people have this naive fantasy that there should be nothing toxic, that we should ban all toxic things from the earth. Well, snake venom isn't going to be banned anytime soon. But even the synthetics, as we call the things we make from elements, we need chlorine as an antiseptic. Why? Because it's toxic. against bacteria that are trying to kill us. It stopped the spread of cholera in water, for example. And it's still used widely in the world, not only as a bleaching agent, but as an antiseptic, antibacterial. So I had to leave. Since then, Greenpeace has figured out, and the rest of the movement has figured out, a whole bunch of campaigns that are fake. And if you look at all these campaigns, as I go through them, you will see that every one of them is based on something that is either invisible or so remote that no one of us could go and verify its truth with our own eyes. Now, the first principle of science, as in Galileo and Darwin and all the rest, is observation. Seeing something or sensing something with a microscope or a Geiger counter or a telescope or another instrument along with it, which basically extends our senses out into the real world where we can observe things happening. And the second most important rule is replication, where if the same thing happens over and over again under similar or identical circumstances, you start to get a strong belief in the truth of this relationship between these things, cause and effect. So let's look at this. All nuclear plants should be shut down due to the dangers they pose. That is all surrounded around radiation, which is invisible and cannot be detected by the average person unless they own a Geiger counter. How many of you own a Geiger counter? One, right? And you're probably very much the exception in the general population. Nuclear reactors are the safest electricity technology in terms of fatalities per generated electricity that there is, much safer than hydroelectric. 90 people died in a hydroelectric accident in Russia not long ago. 250,000 people died in a hydroelectric dam breaching from an earthquake in China in 1975. So actually, hydroelectric is more dangerous than many of the other technologies, but nuclear is the safest. Polar bears are in danger of extinction. In 1970, there were about 6,000 polar bears. Today, there's 25,000 polar bears, and they still say they're in danger of extinction. A bunch of government-funded scientists go for a couple of weeks to the Arctic, look at some polar bears, find one that's dying of starvation, come back with the picture, get it in National Geographic, and apply for their next year's funding to go back again for 2 or 3 weeks. And this has been going on over and over and over again for years. Meanwhile, just recently, you may have read that the Nunavut government, along with agreement from the whole Circumpolar Conference of the Inuit, says there's too many polar bears because they're eating people. And the climate crazies say, oh, the only reason that's happening is because climate change is driving them into the villages because they're desperate for food. Well, one of the reasons they might be desperate for food is they're overpopulated. So there you go. There is a great plastic garbage patch the size of Texas in the Pacific. It does not exist. You can't see it because it's remote. But if you look at a real satellite photograph of the Pacific from space, you cannot see anything except the islands that are out there. The Hawaiian Islands are these teeny little dots. There is no Pacific garbage patch. Then they say, albatross and other seabirds, these are remote things, not invisible. Albatross and other seabirds feed plastic to their chicks, mistaking it for food. And Attenborough goes along with that and weeps on the film in the new Blue Ocean or whatever it's called, weeps openly to the camera. He knows full well, I think he wrote The Secret Life of Birds, he knows full well that the reason the mother albatross is feeding a piece of plastic to the chick is so it will go in its gizzard where it can, just like a pebble does in a land bird, grind the food that they can't eat, can't chew because they got no teeth. Birds have 2 stomachs, one gizzard and one stomach like ours. They normally pick up pieces of pumice from the sea, from the floating on the sea, because it's a rock from underwater volcanoes that floats because it's full of air. And so they use that a lot. But often there's not much pumice because there weren't many volcanoes. And so they resort to nuts and pieces of wood. Now they have bits of plastic. and they put them in the chick on purpose. Before the chick fledges, they put a big bunch of it in there to get that thing fat quick and digest its food faster, because the mother wants the chick to be able to feed itself. And so they load it up full of all this stuff to digest their food, and then before the chick flies, it barfs out what's called a bolus, B-O-L-U-S, which is a big wad of all this solid stuff it's had in its tummy while it's been in the nest, and for the rest of its life it gathers its own stones, but there's of pumice, because there's no rocks in the ocean floating around like there are on the land for birds to swallow to grind their food. So that's what's going on. The coral reefs are dying all around the world. They said in 2016, April, 93% of the Great Barrier Reef is dead, dying, or about to die, depending on which headline you read. There was a major bleaching event in the Great Barrier Reef. Almost all of it was confined to the northern third, where 97% of the reefs in the northern one-third had some bleaching, was the actual fact. That could have been 1% of each of those reefs, because 97% of them had some bleaching, but some could be anywhere from 1 to 50%. It was actually nowhere near 93% of anything, right? And then 2 years later, now, headlines are coming out saying coral reefs show incredible ability to recover from bleaching event, right? But they're not, it's not getting the worldwide coverage that the original bleaching event did. And also, the highest biodiversity of coral and reef fishes is in the warmest seas in the world, and they are not the Great Barrier Reef. They are the Coral Triangle. Indonesia, Polynesia, the Solomon Islands forms the triangle. I've been there snorkeling twice for 2-week expeditions. You would not believe it. Go there if you're a snorkeler, or if you want to learn to be one, go there. It's amazing, because the soft corals are there that undulate in the currents, and the fish are hundreds of species. This is the warmest oceans in the world. And the truth of the matter is, coral reefs have survived for 400 million years, during which time the Earth was much warmer than it is today, almost the entire period of time. So the thing about coral reefs dying is totally a crock. Then you have genetically modified crops pose a danger to human health and the environment. Back to the invisible. Where is the devil? Where is the ghost in the seed of genetically modified foods? Has anybody seen it? Has anybody put it under a microscope so we can see it? No, because there's nothing there to see. There is nothing there. This is a complete hoax. Substantial equivalence means there is nothing different about the GM variety from the many non-GM varieties that is in any way significant to anything, except it's now resistant to the larvae of moths and butterflies in the case of BT varieties. But nothing in there poses any harm to anyone, and yet they've made people label it. They've turned Monsanto into an evil giant. They're a seed company that also is crop protection chemicals. Hydroelectric dams should be torn down and no more built. No more built applies to Site C in British Columbia, 1,000 megawatts of clean hydroelectric renewable energy. The Greens are opposed to hydroelectric energy, even though it is renewable. The only problem with it is it's really cost-effective and works 24/7. They don't like things that are reliable. Pesticide residues in our food cause cancer, birth defects, autism, and brain damage. Zero evidence of that, according to the Cancer Institutes of the US and Canada in a joint study. Yet 30% of cancers in humans are caused by tobacco consumption, and 35% are caused by bad diet, mainly too much fat and cholesterol. Fossil fuels should be banned as CO2 is causing catastrophic climate change. CO2 is invisible, so they can make up any story they want about it. Salamanders are getting shorter. The quality of red wines is declining drastically. Any number of BS stories that come out every day from these people. They just make stuff up. So I'm going to focus on this last one for quite a while here. There's the curve. It's called the Keeling curve because Mr. Keeling established the recording station at Mauna Loa on the top of the big island of Hawaii to be away from industrial sources. And they say that this is causing catastrophic human-caused climate change or global warming. It is not, and I will demonstrate how we know that. But not everybody believes that. These people not only believe that CO2 will cause catastrophe, but that it already is. All you have to do is look outside your window, they say. And I look outside my window and I see a beautiful mountain range with a glacier on it and covered in trees and an ocean in front that's full of life and birds and fish and ducks. And I'm going, what am I supposed to see when I look out the window? I challenge the whole climate change alarmism people. Name me one factor in weather or climate today, because they say weather and climate are different, when in fact climate is just the average weather. But okay, they're different in that sense. Name me one factor that is anywhere near out of line with the last 10,000 years of weather and climate in the Holocene glacial period we're in now, the interglacial period. Nobody has named a single thing that they say is out of line with anything that has happened for 10,000 years. Because there isn't anything happening today that is anywhere out of line with the last 10,000 years. So right off the bat, why would you blame CO2 for nothing? What's it being blamed for if there's nothing happening that is any different than it was for 10,000 years? This is NASA at its worst. They do good things too, but they also collect over $1 billion in climate change research money from the federal government in the United States. You'll remember when they kept sending missions to Mars, every time they wanted to do a new one, they would say, yeah, but there might be life on Mars. You never know. We might find it there, right, to get the money, because that tweaks people's interest if there might be life on Mars. The very first Mars lander proved there was no life on Mars. I know my friend James Lovelock of the Gaia hypothesis, who is a medical doctor and a chemist and was hired by NASA for the first Mars lander to design the life detection technology. When it came back, he said there is no life on Mars, and he did that by understanding the chemical equilibrium between the rock surface and the atmosphere. For example, if you found oxygen on Mars, you would know there was life there, because oxygen is all life created on our atmosphere. Things like that. He found that the atmosphere was in perfect chemical and physical equilibrium with the surface, and therefore there was nothing altering that. And therefore there was no life on Mars. But they brought that all saw out about 50 times in the next 40 years, or 30 years, in order to justify their Mars missions. And they do this. CO2 controls Earth's temperature to keep getting that funding from the federal government. No credible scientist would ever say that carbon dioxide is basically the only important factor in the climate of planet Earth. But that's what they stoop to say. That's what I mean when I say this issue has destroyed the Enlightenment and scientific integrity more than any in the last centuries. One of the reasons not to believe the Intergovernmental Panel on Climate Change is their mandate, which inherently conflicts their position. They are mandated to study a change of climate which is attributed directly or indirectly to human activity. Therefore, if they were to find that humans are not the main cause of climate, or that it was not dangerous even if we were the main cause of climate, there would be no reason for them to exist. So they're automatically mandated to side on the side of apocalypse or something really bad. Otherwise, why would we spend billions of dollars on them if there was nothing to worry about, which there isn't. Not on this front anyways. This quote has been repeated many times, but the IPCC has never emphasized it. The climate system is a coupled, in other words, everything is interconnected, non-linear, in other words, things just don't go in straight lines, chaotic, in other words, everything is chaotic, which leads you to complete unpredictability with any kind of normal mathematics, and therefore long-term prediction of future climate states is not possible. And then they go ahead and predict the climate states for the future. They purged this website in November 2018, because I went to find it the other day while I was preparing this presentation. Page not found. Page not found, page not found, everywhere it used to be, because it was in quite a few little locations, this quote. It's gone. The Wayback Machine shows clearly that it was purged in November 2018, because it was recorded over 40 times before that from 2001 when it was first published by the IPCC. That's why you shouldn't believe them. Here are the G7 leaders just before the Paris meeting in June, well, 5 months before the Paris meeting, in Indonesia, meeting and agreeing to phase out fossil fuel use by the end of the century and simultaneously ending extreme poverty and hunger. At least Stephen Harper had the decency to bow his head in shame. This, when I saw this, I just could not believe what a conservative from the oil patch agrees to phase out fossil fuels for the whole country of Canada while on an international mission with the other 6 G7 leaders. He could have abstained. When I asked the man running for the Premier of Alberta why his fellow conservative would have done such a thing, in public I asked him, he said it must have been aspirational. Does aspirational mean you don't really mean it? I didn't think so. I think it means that's what you would aspire to. Isn't that where the word comes from? So Stephen Harper aspired to ending fossil fuels in Canada quite some time before the oil sands went dry. Because I think they're good to 2,500 or something, aren't they? Yeah, that's what he did. And we must never, ever let a Prime Minister of Canada that comes from Alberta do that again. Well, for anywhere else for that matter, says Danny, and of course he's right about that. Yeah, or Saskatchewan, or anywhere, but particularly from Alberta, because it's some kind of treason. And there's the great celebration, the great victory, the great agreement where all the nations of the world, well, eventually with the exception of the United States of America, where all the nations of the world agreed that this crisis must be averted and we must move forward quickly to reduce fossil fuel consumption and CO2 emissions all over the planet. This is why, the next slide, Canada should quit Paris. Quitting Paris is the most important and only real movement that we can do that is symbolic of rejecting the whole ball of wax. You can't just say, oh, maybe we should reduce CO2 by this much or that much or have a carbon tax of $10 or $20, all this talk. Rejecting Paris means you reject the whole thing because it should be rejected out of hand because it's false. It is a hoax. It is a lie. It is a cheat on the part of China in particular. You see this little downturn here? This was invented for the Paris meeting. This is not true. This is a lie that China reduced its CO2 emissions. Bloomberg and all the rest of the lackeys and usual suspects ran this graph. This is the truth. May 2018, China's emissions set for fastest growth in 7 years. It's been going up since then to here. We're here now. That is the truth. And that is what we should notice. Canada is down here. There's India, there's Europe and the United States. Europe has actually done this by sacrificing themselves to some extent, although in 1990, when Eastern Europe reunited with the West, they rebuilt all the factories to modern standards and made them twice as efficient with fossil fuels. So a lot of the reduction in European CO2 emissions, where Germany is the biggest emitter, was the result of retooling East Germany. In the United States, it's the result of fracking natural gas and using it to replace coal, with about a 10% swing in the electricity production. So neither of these things had anything to do with the Paris Agreement or the Kyoto Agreement or any international agreement. They all just happened because of certain things. Whereas India and China, they're doing more to green the earth than any other countries, except, well, these ones here are still doing a pretty good job, but this is going to come up to about here sometime. That's why we should quit Paris. Okay, time scales. This is 500 million years plus. These measurements are made from marine sediment cores, where they drill down into the sediment at the bottom of the ocean, which goes back for more than 500 million years. But for the first 500 million, it's pretty accurate in being able to use proxies of different isotopes to determine the temperature of the Earth and the CO2 content of the atmosphere at that time. There is very little correlation. Here's some correlation here. Here's some correlation here. But remember, this is a logarithmic scale, so this is only 65 million years here, and this is 500 million years here. So look at this. They are exactly opposite to each other. Not correlated, but negatively correlated. And this is 50 million years here of declining temperatures and 150 million years of declining CO2. So the first 100 million years here, temperature was going up while CO2 was going down. There is no way that this historical record in any way verifies a causal relationship between the two. Simply does not, at the longest time scale that we have decent data for. Here is a very strong correlation between ice cream sales and shark attacks. There's actually a website on correlations that are ridiculous. I forget what the second word is, but if you go on the internet and look for spurious, yeah, spurious correlations, it's a beautiful thing. Like Tom Hanks' movies are correlated with something to do with earthquakes. But, you know, things like that. It's just full of it. Correlations are much more common than causations, because very often a strong correlation like this one, where obviously shark attacks don't cause ice cream consumption or vice versa, but a third common factor causes both of them. In this case, summer temperatures cause them to peak, because that's when people go swimming and get attacked by sharks and come back on the beach and have an ice cream cone because it's hot. You have to always look for those. Here's the last 65 million years. Here's where the dinosaur extinction occurred, where the asteroid hit Yucatan. It was an asteroid that was at least 60 miles in diameter. It penetrated the Earth's crust and brought the magma from below into the stratosphere, where it darkened the Earth for many years and killed 75% of all the species into extinction. But they have since recovered in more numbers than they were before. That's been the history of the extinctions. Here is the Eocene thermal maximum. Earth was ice-free here. This is when Antarctic began to glaciate. The Antarctic, with all water around it, doesn't heat up as much as the northern hemisphere with all land around it at the top. So the Antarctic started to freeze up way before the Arctic. And then the northern hemisphere glaciation began about 5 million years ago. Up until here, Canada's Arctic islands were covered in forests. The remains of those forests are still there. And 2.5 million years ago, right about where it crosses this line, is the Pleistocene Ice Age. You can see from here that the last ice age was here, 300 million years ago. This ice age lasted for 100 million years. This ice age has only lasted 2.5 million years so far. We are still in it. It's called the Pleistocene. And here is the last 400,000 years of the Pleistocene. You can see from this, these are the interglacial periods like the one we are in now. These are the depths of the ice ages. See how it's a sawtooth shape? You go into the ice age, into the glaciation, sorry, not ice age. The ice age is the whole thing, 2.5 million years. There's been about 44 glaciations during that period. As you go into the glaciation, it's slow, takes 80,000 years. But you come out of it quickly. Then some blips, because the Milankovitch cycles are 3 and they're all overlapping and they don't act in perfect synchronicity, but they are what cause these temperature changes. This is the same graph that Al Gore used for his primary fraud in Inconvenient Truth. He said, look, they're obviously strongly correlated, so this proves that CO2 causes the ups and downs in temperature between the glacial periods. No. Why would a change in solar radiation, which is what the Milankovitch cycles amount to, with the changes in the tilt of the Earth and the shape of the orbit, why would the changes in the orbit of the Earth affect CO2? There's no plausible reason for that. But changes in temperature, when the oceans heat, they give off gas. When the oceans heat, they give off gas. When the oceans cool, they absorb gas. And this is what's happening here, is the oceans are breathing. The oceans contain 45 times as much CO2 as the atmosphere. So a 1% change in oceanic CO2 composition from outgassing and ingassing creates a 45% change in the atmospheric level of CO2. There it goes. But there's one more thing to notice here. Note that the temperature of the interglacial periods is declining, and the temperature of the glacial peaks is declining. The Pleistocene is still getting colder by these graphs. In other words, we may just be at the beginning of the Pleistocene, seeing as though the last one lasted 100 million years, and this one is only 2.5 million years old. But predictions are not data. Remember that, and always remember that. Predictions are not data. And the output from computer models are predictions, not data. And the output from computer models depends only on what you put into the computer model. If you put some numbers into a computer model and run it 5,000 times, it will never come out different with the same numbers going in. That is why they are not a crystal ball. They are a tool. There is no crystal ball, as you may know. This is a fun graph. This is the Holocene period that we're in today. This is the Milankovitch cycle called obliquity, the tilt of the Earth. This first period is the Holocene climate optimum, when the Sahara was green and goat herders roamed across it. They have maps showing the names of the towns that were all across the Sahara at that time. They all had to move 5,000 years ago when it broke into the neoglacial. What does that mean? It means new glacial period. That's because the temperature started to drop. This is the beginning of the descent into the next glaciation. It will take 80,000 years if it follows the pattern of the previous 4. There you go. The Holocene conundrum is the fact that CO2 came up from about 260 to about 280 parts per million while the temperature dropped. It's called a conundrum because we don't know why. And there are some things we don't know why. Actually, in the climate, most things we don't know why. This illustrates the neoglacial. These are bars indicating the number and degree of which glaciers are advancing during the neoglacial, because they've been on and off. You can see there's periods where no glaciers were advancing, where they were retreating, still retreating after they almost all had retreated coming out of the glaciation. This just goes back 12,000 years. The peak of the glaciation was 20,000 years back. So this is the Little Ice Age. The Little Ice Age, peaking at 1700 AD, was the coldest it's been since we came out of the last glaciation. So we are apparently moving into a new glacial period, but at the same time, as you can see here, there are ups and downs within this descent, and there's this little uptick here, which is now. This is the modern warm period. This was the Little Ice Age. This is the Roman warm period, the medieval warm period. This is the Roman warm period. This is the Minoan warm period. These are about 1,000 years apart. So there's ups and downs during the downward trend. So there's cycles upon cycles upon cycles. So depending on what time scale you're looking at, you could say we're warming now, because we are. And if it goes according to the last 1,000 years or 2,000 years, we will warm for another 200 years, maybe another degree or so. But then the cooling will resume. And right now we may be in a mini cooling period due to the grand solar minimum, which happened in the midst of these 500-year trends down and up. Because there's other little cycles on top of the bigger cycles. And the El Nino and La Nina are cycles that are even smaller. They're on a decadal basis. A few years go by when these cycles happen. So you have to think of it as cycles upon cycles upon cycles upon cycles. This is the longest thermometer record in the world, 300 years about. And actually, I think it's more than that. And this is the trend. This is about the peak here, 1700 here. This is the peak of the Little Ice Age, or the nadir of the Little Ice Age, coming out of the warming period of the medieval, going back there, down to here, then up and up and up and up and up. But this is not very much up. It's like 1 degree Celsius. This is CO2 emissions on an annual basis. This line is not following that line very carefully. This is the last time the River Thames froze over at London, 1814. Here are all the years when the River Thames froze over during the Little Ice Age. They had big fiestas out on the Thames. It was about twice per decade. This was the last time. 200 years ago. And we're blaming CO2 for the continuation of this slight warming trend. This is from England, from the Hadley Research Center, Center for Climate Prediction. This is from 1910 to 1940. It warmed. Then it cooled. This is when they said another ice age was coming on the front of Newsweek and Time, and in the New York Times, and in scientific literature. And then it started warming again. How do they know what did this isn't the same thing that did this? They don't. They just make up stories. Because this couldn't possibly have been caused by CO2, because we weren't putting enough out at this time to do. Here's where the CO2 started in earnest around 1960. And they're coincidental with this continuation of the modern warm period. They're saying we're responsible for that, but not for this. This is the work of Willie Soon and the Connolly family, mother, father, and son, all with PhDs in science in Ireland, collaborated with Willie Soon, who's originally, he's from Malaysia. So these are some of the most brilliant people in the world today. And this is a big paper in which they showed that total solar irradiation is far more strongly correlated with the temperature changes that have occurred since 1880 than CO2. This is real. And they took out all the urban weather stations to avoid the urban heat island effect. They just used rural stations around the world in China, North America, and Eurasia. I don't know if this is true anymore, so I'm not going to use it. I told you about this already, how much ice there was on these cities just 21,000 years ago. This could happen again, almost certainly will happen again. The next ice glaciation is predicted to be less severe than this one because the Milankovitch cycles are not quite as in sync as they were for the last 3 or 4, but they're going to be again someday, and who knows? We don't know. We never will. This is the sea level rise that occurred as the glaciers melted coming out of the last glaciation, called the mid-latitude low-elevation glaciers, the ones that reached down way south of here into the northern tier states. This was 120 meters of sea level rise, approximately 420 feet. And for the last 7,000 years, it's been pretty flat. Now they put this graph this way, indicating there's been a continual slight rise in the sea for the last 7,000 years. But a lot of people don't believe that because of this. These are islands at Papua at the equator in Indonesia, where there's very few storms, if ever, and where the sea laps gently on the rocks of the island. How could this happen if the sea was continuously rising? It could not. It's estimated this took 7,000 years to happen. So what's been happening is through these 1,000-year warming, cooling, warming, cooling, warming, cooling, the sea has been up and down, up and down, up and down, a foot or 2 or 3 maybe, all through those cycles. In other words, coming into the Little Ice Age, the sea would have been dropping. And since 1700, the sea would have been rising slightly because the temperature is increasing. And indeed, sea level rise is an issue, especially in Florida and Holland, where the land is flat. So I tell people it's simple. Whatever's causing sea level rise, okay, it could be a lot of different things. But it doesn't matter because you only got 2 choices if you're on the sea and the sea is rising. You either move to higher ground or hire the Dutch. Those are your choices, right? There is no other choices, or a combination of the 2, I suppose. But if you're on Manhattan, it makes sense to move to higher ground because it goes up steep. If you're on a real flat place where the water's going to go inland for 20 miles, it makes sense to build fortifications like they have in Holland. It's easy to make new land. The whole airport in Osaka is built on fill. The Middle East, they're building these beautiful shaped islands everywhere to have oases and resorts on. They're making these islands, right? We know how to build dikes. We've been building them for centuries, the centuries during which the sea has been rising. So I wouldn't call it like the end of the world, as AOC is saying. You know, it's going to be World War II. It's not quite World War II. You won't have to run. It will not catch up with you while you are walking away from it. I'm just going to show one indication of no significant change in extreme weather in the last decades. As a matter of fact, there's a reduction in tornadoes in the United States. There's a reduction in hurricanes hitting the continental United States right now. There's a reduction in drought. There's a reduction in floods in many parts of the world. There is no upward trend in all these things, and even the IPCC corroborates that. They say it very clearly, but the media and Greenpeace and the rest of them, they're trying now to make us think that every extreme weather event is because of climate change. Just a few years ago, they were telling us, oh, no, that's not climate, that's just weather. When we said, oh, it's kind of cold last winter, they'd say, oh, no, that's not climate, that's just weather. Now it's only about weather because the climate isn't changing much, except for there's still weather events that every time there is one, they say it's caused by climate change. CO2 is the most important food for life on Earth. All life depends on CO2 for its existence. That is the only place the carbon and carbon-based life has come from. The CO2 came from the Earth, from volcanism, but much less of it is coming out today because the Earth has cooled due to the decay of the radiation that makes it hot inside in the first place. And now the Earth is way cooler than it was at the beginning of the Earth when most of the CO2 was put in the air. That's why CO2 has constantly declined in the early years, but I'll tell you why it continues to decline up until we came along. Oh yeah, they say, these crazy people, remember how these crazy people said it's good to talk to your plants, that it's going to make them happy? You are breathing 40,000 parts per million of CO2 on them when you talk to them. That's what they eat for breakfast, lunch, and dinner. That will make them happy. It will make them grow faster, just like the plants in a greenhouse where the growers increase the CO2 up to 800 to 2,000 ppm sometimes, but 800 to 1,200 is the average range. Gives them 40 to 60% increase in yield inside the greenhouse just by putting more CO2 in there. Outside in the real world, on a farm, where the farmer can't add CO2, but can add fertilizer and water, CO2 is always the limiting factor to growth because the plants are being given their nutrients and their water and what sun shines. You can't increase that. But you can increase CO2 in a greenhouse, and you can also increase CO2 by burning fossil fuels outdoors. This is where the carbon is. This is a complicated looking map, but it really has some few components. Let's look first at the trees and plants. This is the respiration, the decomposition from the soil. And this is plant respiration, breathing out CO2 at night and when they decay. This is litter fall, falling on the ground. This is photosynthesis, pulling CO2 out of the atmosphere. These numbers don't balance because some of the CO2 that we're putting into the atmosphere, this green one, and I make this one different from all the others because of the difference, which I'll explain in a minute, of the nature of it. This is how much CO2 there is in the total atmosphere, 850 billion tons of carbon as CO2. This is all carbon. So it's 850 billion tons of carbon as CO2 in the atmosphere. So just the numbers in plants alone, there's almost as much CO2 in plants as there is in the whole global atmosphere. That's how low it's got. Used to be way higher than that. The ocean contains nearly 50 times as much CO2 as the atmosphere, as I mentioned previously. Fossil fuels under the ground, 5,000 to 10,000 billion tons. Compare that to the amount in the atmosphere. You can see how we can have a big influence by burning a lot of these. But here is where the carbon really is. In carbonaceous rocks, limestone and dolomite, calcium carbonate, calcium magnesium carbonate, all containing carbon from CO2. I'll explain how this happened. This is where the main body of carbon in the earth is, and all of these carbonaceous rocks are of life origin. They didn't come out of the ground by volcanoes. They were made by living creatures, all of these rocks. They are limestone and dolomite. So some people say that because we're only putting 10 billion tons a year of carbon into the atmosphere, and plants are putting 120 billion tons of carbon into the atmosphere, that therefore our contribution to this is only a small percentage. That is confusing what we call in economics the balance sheet with the cash flow statement. This carbon is circulating on an annual basis. Decay in the fall, growth in the spring. That's why the Keeling curve has all those little bumps in it, because the CO2 goes up and down on an annual basis. This 10 billion tons is an addition to the existing carbon cycle in the atmosphere and the land and the oceans. So it adds to the balance sheet, whereas this is just a cash flow, in and out. A cash flow is a measurement of change over time. A balance sheet is a snapshot in time. So the balance sheet of the global atmosphere has gone from about 500 billion tons before we started emitting CO2 to 850 billion tons, and we might as well assume that we did all of it. Because actually, only about half of our CO2 emissions, only 5 billion tons of this, are actually ending up in the atmosphere as a measurable increase. The other half is going somewhere else. We think the other half is going into plants in what's called the greening of the earth. But before we get to that, let's look at the culprits. These species, called calcifying marine organisms, range from the microscopic coccolithophores, which are a plant, phytoplankton, the basis of the food chain in the sea. Over 500 million years ago, many marine species learned to control the crystallization of calcium carbonate in order to make armor plating for themselves. There's a soft body inside this rock plating that they have made for themselves. These are the foraminifera. They are an animal, a zooplankton. These little holes in this mesh, these guys fit in there perfect. So these go in huge blooms, huge herds through the sea, into the blooms of the coccolithophores and suck them up and eat them. They are the next stage up in the food chain. All of this is calcium carbonate in all of the shellfish, including the crabs and prawns and coral reefs. You can imagine how much biomass, how much mass there is in the coral reefs of this world, especially when it was warmer, when they occupied a much wider range in the oceans. 100 million billion tons of carbon have been sequestered by these kinds of species into the bottom of the sea, where they've been lost from the cycle, the annual cycle of plants and oceans and air. They've been permanently lost. So what we are doing, here's one of those calcareous marine organisms that lived just fine at 2,000 ppm before the dinosaurs went extinct. These are the ammonites. They went extinct with the dinosaurs. They had two great big eyes coming out of here and some tentacles to catch things with. But this is a mock-up, but this is how big their shells were, and there were billions of them. And when they died, they all fell to the bottom of the sea and took the carbon with them. Here is the generalized trend of carbon dioxide in the global atmosphere for 500 million years. I could talk for 20 minutes just about this one slide, but don't worry, I won't. You can see that CO2 was drawn down heavily during the Carboniferous when trees evolved. Of course, trees amount to about 90% of global biomass, and they're made of carbon. 50% of wood is carbon. So that carbon came out of the atmosphere. Why it came so low, we don't know for sure, and that's a whole other story. That's why I could spend half an hour right here. But it came back up again for some reason to about 2,000 to 2,500 ppm. In other words, about 5 times what it is now, and about 10 times what it was before we started emitting fossil fuel CO2, and has gradually and inexorably gone down over that time. This is not the balance of nature. This is a constant depletion by marine calcareous organisms, which were brilliant in their invention of armor plating, but inadvertently presaged the end of life by sucking all the CO2 out of the ocean and thereby the atmosphere. Because when you take CO2 out of the ocean, more comes down out of the atmosphere to replace it in an equilibrium, chemical equilibrium between the two. So, this little uptick here, that's us. We did that inadvertently by burning fossil fuels. So both stages the massive sequestration of CO2 over millions of years by marine calcifiers was inadvertently causing CO2 to go down, and the discovery of fossil fuels and their adoption widely for 80-some% of civilization's energy inadvertently replaced a balance to the global carbon cycle and saved us from a continued downward spiral. As you can see, because the oceans were cold at the height of the last glaciation, CO2 fell to 180 parts per million. This is only 30 parts per million above the death of plants. It's thought that high elevation forests died because as you go up, the air gets thinner, and therefore CO2 concentration gets lower. It's thought that those forests died during these peaks of glacial periods. Also, you can see here when you stretch this thing out from what I showed you before, like I showed you 400,000 years, now I'm showing you less than 50,000 years. You can see that temperature goes up first and CO2 follows it. The lag is approximately 800 years, which one would expect because of ocean circulation. So, this is what was going to happen if humans had not discovered fossil fuels and started to burn them. I first showed this and this hypothesis of the depletion of CO2 by marine calcifying organisms not being replenished by volcanoes anymore because the Earth has gone cold in 4.6 billion years. There's the curve. This is what we know for 150 million years. This is what we know. This is what would have happened, presumably. When you don't know what the future is going to bring, extrapolate what has been happening for 150 million years, because there's no reason to do it any other way. Because we don't have any reason to go up or down with that line. But we do know that if this had happened, within 2 to 3 million years from now, life would begin to die on planet Earth. We are not the enemy of nature, but its salvation. I presented this to the Global Warming Policy Foundation in London at the Society of Chemical Engineers in the center of the city in 2015, just before the Paris meeting. This has not been refuted by anyone. No one has given a critique of this hypothesis, and a lot of people know about it. They just remain silent because there is, as far as I know, no valid critique. I've put all the pieces together, and it took me 30 years to get to this point. In all these different pieces moving around in this system over 500 million years, this is what was going to happen if we didn't do this. The greening of the Earth is because of this. A lot of you know this picture. This is Craig Idso, Sr., I believe, and his son is just about to publish a white paper for our CO2 coalition on all the evidence about the increase in growth of plants due to the increase in CO2 that we've caused. And here is the greening of the Earth as first shown by the Commonwealth Science and Industry Research Organization in Australia. 35 years of satellite measurement showing that the greening is most pronounced in the driest parts, because not only does CO2 elevation as a fertilizer cause increased growth in plants, it makes them more efficient with water. Because the higher the CO2, the less they have to open their stomatas, or the less number of stomatas they have to make, which are a passageway into them from the air, which allows water to come out, transpiration. And when they have less surface area for water to come out, they hold the water better, conserve it better, and now trees are spreading out into grasslands across the dry parts of the U.S. Southwest, and indicating the proof of this fact, that the trees and the plants are more efficient with water in higher CO2. Now NASA has confirmed that carbon dioxide fertilization is greening the earth. Here's their map, again by satellite. So they are starting to realize, although if you read the text under this, it tries to say that this might not be all good, you know. But that's just a sop. This was an international team of 32 authors from 24 institutions in 8 countries. So it's not like one crank producing this here. This is the real deal. This is what's happening to the sun right now. NASA is now also verifying that this is causing a cooling of the upper atmosphere. It's complicated, but CO2 is actually one of the main reasons that the radiation from the sun escapes back to space, because it's the one that's radiating it out in the upper atmosphere. So it also cools the Earth as well as warming it slightly, but insignificantly, through its greenhouse properties. But its radiation properties in the upper atmosphere are actually a more significant factor in that they help cool the Earth. The Earth can't cool by convection or conduction, because convection and conduction do not work in space, in a vacuum. The only way the heat can escape the Earth is through radiation. And that's happening in the upper atmosphere. Okay, just briefly, you've seen the proposal for the Green New Deal, which basically says we get rid of coal, we get rid of oil, we get rid of natural gas, we get rid of nuclear, and by the way, they also hate hydroelectric, which isn't a big deal in the United States anyways. It's like 3% of their electricity. Nuclear is actually more like, in the States, more like 12 to 15% of their electricity. So it actually, and it's baseload reliable power, 24/7. They say that if Ocasio-Cortez gets her way and bans all fossil fuels, that it'll eliminate 10 million jobs in the United States. Oh, is that all it'll do? I'll tell you what it'll do. Say we ended it overnight. No more fossil fuels. The rot would begin in the center of the urban places, because the food wouldn't get there. The food would be stopped before it got there. And how the hell would it get there anyways? People packing it in there? Are they going to breed enough draft animals to move the food into the cities? Trucks can't run on batteries full of food with 40 tons of food in them. So the people will begin to die in the center of the cities from the simple matter of starvation. There'll probably still be water available if the water systems are working for a while. But basically, people will begin to starve from the centers out. And guess what people will then eat? Right? Like in boats at sea that don't get found. That's what would happen. It's a lot worse than 10 million people losing their jobs in the oil industry. And as it radiated out from the center, way more than half the population of the Earth would die as a result of no food getting to where people need it, or being grown or harvested without fossil fuels. Will they go back to oxen like overnight in 10 years from now? No. That's what would happen. And even more amazing, there would not be one tree left on this planet. In how many years would it take before every tree had been burned for fuel to stay warm and cook? At the very least, they might even figure out how to make some electricity with it, but there wouldn't be very many people left to do it. That's what would happen if we ended fossil fuels, and for goodness sakes, would someone please explain that to the idiots? All they're saying is they're going to lose some jobs. You see what I mean? How do you get the food into the big supermarkets in the cities without gasoline and diesel oil? You just don't. It's impossible. And if you tried, they'd hijack you at the border of the town. Take your food away from you there.
High-speed rail.
High-speed rail, that's it. That's the solution. you know, all you need is wires for that. You just need to hook it up to the wires, you know, the wires that are running across the country there. Yeah, just hook it up to them. Anyways, fossil fuels are 100% organic, as in the scientific meaning of the word organic, which is the chemistry of carbon, as opposed to inorganic chemistry, which is the chemistry of everything else. Organic as a marketing term in food is nothing but a marketing term in food, and it's fake. And Whole Foods charges twice as much for a fake advantage, which does not exist in this world at all. As a matter of fact, GMO products are likely to cause less aflatoxin poisoning than non-GMO products because the worms didn't burrow into them and take the mold in there with them. Produced 100% by solar energy, all the fossil fuels. That's how they were made. From life. They were made from life. They were not made from death. They were not made from outer space. They were made from living things. When they burned, they produced the two most important foods for life, because that's what they were made out of: water and CO2. And it is also the largest storage battery on Earth. And it's a solar storage battery, not a lithium storage battery. It's a renewable storage battery, or at least renewable in the sense that it's organic and made of life. That's what we need to teach people. And we need to teach them this too. There's a whole bunch of charts about this that has to do with wealth and other stuff, but just in terms of how long people live, from 1800, average age at 25 or so, you know, it started going up here as industrial age came on, but then boom and boom. How do you argue with that? I'm not saying that CO2 caused people to live longer because they were breathing CO2. CO2, the result of fossil fuel combustion, is what made people live longer and be wealthier and healthier and have more personal freedom, which they also want to end by having no more airplanes in the world. So you have to take a fast train to southern Mexico now. Oh no, Mexico won't have trains, just the States. And not Hawaii either. And how are you going to get to Alaska unless you build a fast train through BC or Alberta? Okay, there's the oil sands, there's Edmonton, there's Calgary. As you know, every square inch of the oil sands must be rehabilitated back to a boreal forest ecosystem. When are they going to do that with Edmonton? Or Calgary here? Or Sao Paulo, or Tokyo, or Los Angeles? When are they going to restore those places back to their original ecosystems? Never. But they're going to restore the oil sands right back to how it looked before. There's what it takes to clean up the world's largest natural oil spill. Got to have one of these. Canada, build this pipeline. So I told you I had 3 words for you. The first 2 are quit Paris. The third is pipelines. And I think it's important to narrow down your objectives and to be very strategic in what you're aiming for and not to spread yourself too wide. If you just focus on quitting Paris and building pipelines, everything else falls together, as far as I can see. Is there another bigger word or as big a word that I should add to my 3 words? Yeah, well, that's how we're going to get this. And build this pipeline too. Germaine, thank you so much for such an uplifting presentation you made today. I didn't know some of these facts, and it's nice to know, as we should know in our hearts, that people are good everywhere and smart too, you know, and that politics distorts the situation so bad when people say bad things, nasty things, and that's all the media broadcasts then. They never talk about the nice things people are saying about each other. So yeah, let's build this. And I so think what you said about putting it away from the towns and cities is logical. It's probably easier actually. There's not so much infrastructure in the way. You know, I mean, it just makes sense. You can build little feeders off it coming down to where you want that if you need some facilities that are further south. But the main line, that's a great idea, and we should tell everybody about that. So it's okay to have tankers coming in to the east coast of Canada by the hundreds. And a pipeline from the States. That's how a lot of the oil in the east is brought in too, is by pipelines from the States. But it's not right to have pipelines to the Pacific or oil tankers leaving the Pacific side. You know, it's so completely irrational. Actually, I'm a pacifist all my life. I was saying, when talking about this around the table the other day about scrapping when you're a kid, you know. Actually, I have never hit another person. I learned how to talk myself out of that real young, because I didn't want to be hit myself either, because I wasn't a boxer or anything. So, but you know what? This situation makes you want to hit somebody. You don't know who it is, but, well, you sort of do know who it is, but maybe just a mannequin or something, you know, or an effigy, or pins in a doll or something, you know. Some symbolism to express your grief.
We know that you kick yourself in the butt.
Kick myself in the butt. That's what I have to do. Yeah. With my broken leg. Oh no, that happened afterwards. I'm almost done. This is good enough for me. This is restoration of an oil sands mining area. And how could there be anything wrong with that? And it's only open for about 10, 20 years at the most. So for millions of years, this oil lay there polluting the soil underneath the plants, which miraculously are able to grow on it even when it's saturated with oil. And we come along and clean up the oil, spend maybe 20 years opening it up to get it clean again. White Sands is named that name for a reason up there. And then it's put back to a beautiful boreal forest. And goodness me, there may be a tree harvest there someday. I bet Greenpeace wouldn't like that, would they? Actually took some wood off there. And the way they do it, you know, they recontour the land so wildfowl with Ducks Unlimited helping, they make all kinds of habitat that didn't even exist there before because it was all flat, say. When you take flat land and turn it into places where there's pockets for water to collect all around, then the ducks and the geese and other waterfowl, shorebirds come in and different vegetation. You get your bulrushes growing around the edge, which wouldn't grow on a place like this, and you make it more biodiverse than it was in the first place. We know how to do that because we're smart. Ecological restoration is a science, and we're good at it. So there you go, ladies and gentlemen. I tell you, you got my Twitter here at EcoSense Now. If any of you want to get involved in a really informative exchange of information, come to my 30,000 followers. There's a lot of crap there. Every once in a while you get frustrated and you want to kill somebody. But you try to keep your manners and try to just stick to information exchange. You can exchange graphs, you can change maps, you can change documents, you can give websites, you can do anything there. It's a massive information exchange potential. And that's all I use it for. Oh, except to have fun sometimes. But not telling what I ate for breakfast, you know, that's Facebook. On Twitter, we're serious about our conversation, not just about climate, but about environmental issues in general. That's where I learned just the other day through a friend over in Asia that Bangladesh was going to approve golden rice within 3 months for commercial production to start the process of ending vitamin A deficiency in South Asia and Africa. There's what you said you were going to do right here. This is what you're going to do, right? So get on with it. Pipelines. Quit Paris. That's what you got to do right there. And there's the pipelines in North America. We don't have many. We need more. We got an argument there. Look at this. And why the champagne glasses? Because the bubbles are CO2, and we should celebrate CO2. With me, celebrate CO2. Thank you.
Thank you for tuning in to the Grand Solar Minimum channel. This video is a part of our learning series. Many people have been looking for a quick overview of exactly what a grand solar minimum is. Some are here today just curious of the different views of climate change. So let's dive in. As a primer to this video, I recommend my breakdown on the differences between a solar cycle, a grand cycle, and a super grand solar cycle. For hundreds of millions of years, changes in solar activity have been associated with changes from warming to cooling and back again. The long run to the recent peak in activity was the strongest in thousands of years. Despite this, temperatures were not as warm for as long as set during the medieval warm period. The deep dive into the cooler climate in the early 1300s was drastic, causing widespread crop failures and famine in Northern Europe and England. The die-off from 1315 to 1320 is estimated at some 10% of the population. Deaths of cattle, sheep, and horses were severe as well, all due to the turn to cold and unusually wet weather. A new change to what some are calling the modern minimum or eddy minimum is significant. NASA has confirmed solar cycle 25. The next solar cycle is expected to be significantly weaker than that of the current cycle. NOAA has also released predictions that the next solar cycle will be the lowest we have seen in 200 years. This is also supported in Valentina Zarkova's latest research, which predicts the next modern grand minimum of solar activity between 2020 and 2055. Her paper also shows how the warming trends over time are a part of a natural cycle. 200 years ago, we were in what we call a grand solar minimum, the Dalton minimum, an extended lull of solar activity. This chart is an easy visual to see how our solar cycles rise and fall. Right now, we are forecasted for a very steep decline. Like the Maunder minimum and the Sporer minimum, the Dalton minimum coincided with a period of lower than average global temperatures. The year without a summer occurred during the Dalton minimum in 1816. The prime reason for that year's cool temperatures was the highly explosive 1815 eruption of Mount Tambora in Indonesia. This was one of the two largest eruptions in the past 2,000 years. The cause of lower than average temperatures and their probable relation to low sunspot count are not well understood. The most likely cause I have found is from papers that link low solar activity and cosmic rays to volcanic activity. Cosmic rays are currently on the rise. With the modern grand minimum, as history has shown with prior grand minima, we will have these earth changes. With this change comes a threat to our food supply, something many of us have had a glimpse of this year. Last year's crop was not too bad, and yet we are seeing shortages this year. It is very concerning to see the struggles our farms are going through. We have had farms not getting anything into the ground or being flooded out and having to replant to just getting a late start due to poor soil conditions. The numbers are looking bleak for this year's crop, and we are facing a predicted early frost by many professional forecasters. We can no longer take for granted our food supply. We may have passed the breaking point, and only time will tell just how bad by this time next year. To be best prepared, learn to grow your own food and stock up what you can. It is very unfortunate that these natural cycles have been demonized to the masses as global warming, or now, as the temperatures have been cooling, the term climate change. Fingers are pointed at mankind because it is profitable. What a brilliant idea. Blaming mankind for CO2 so the powers that be can assign a tax and penalize its people. They have shown you starving polar bears. The ice caps are melting. Al Gore even promised your children would never see snow. They have twisted this natural cycle into your fault. It is fear for profit, and there is no science that proves CO2 is the main driver of our climate. In fact, most organizations such as NOAA and NASA define the sun as the primary driver of our climate. If this is true, and history has shown this to be true, why would we accept an international organization such as the IPCC, the International Panel on Climate Change, giving us reports that do not even have the contribution of a solar physicist? Think about that for a minute. We have a panel to direct people worldwide on the climate. Yet the panel has 0 solar physicists to contribute the very dire information about our sun. They tout they have climatologists. However, our climate is so much more complex than many simplify it to be. I'm sorry to offend anyone, but a climatologist is not 100% well versed in all variables of our climate. What are some of the variables? Our sun, the solar forcing, our moon with lunar forcing, our magnetosphere, our ocean oscillations, the weather patterns. As I stated earlier, we have complexities like the increase of cosmic rays, which have been linked to earthquake and volcanic activity. There are changes that are happening in our atmosphere, the complexities of cloud nucleation, albedo effect, other space weather, and much more. The variables are complex and need researchers specially trained in each component to gain a full understanding. To this day, I have not found a group of researchers come together to truly assemble the big picture in a professional manner. There is simply no funding for it because the data points to a natural cycle, and that is not profitable. There's a lot of rhetoric, a lot of propaganda, and unfortunately, the mainstream profit machine is not out to protect the well-being of mankind. There's not a group of specialists or a panel that exists that is truly able to decipher what exactly our climate is doing. We must all zoom out and see there are many pieces to this puzzle. As a planet, we face many challenges. Just look at the extreme weather, floods, drought, food shortages. All these will intensify as this cycle progresses. We are threatened by power grid failures from geomagnetic storms, asteroids, political uprising in some countries, the vulnerable state of the monetary systems. These things may happen, they may not happen. The important message I want you to take from this is be prepared. Do not rely on anyone but yourself to get you prepared. This is something you cannot put off. The best practice is to be prepared. We at GSM hope for the best, but prepare for the worst. Have a plan. That is all you can do. I encourage you to research this topic further and research it from all sides. No one truly knows what the future holds. We must learn from our history and take steps to adapt to these natural cycles. You cannot stop climate change. The only thing you can do is adapt. Have you learned from history? How well prepared will you be? I will be covering many of the climate variables and history in separate videos as a part of this learning series. Thank you for tuning in to the Grand Solar Minimum channel. Please like and share.
All right, what's going on, everybody? Just thought I'd jump on and say hello to all of our supporters out there who are watching us tonight. Corey, how you doing? I saw Matt in here earlier. SPACEWEATHER, I've seen you in here a few different times. Thought I'd say hello. There's a couple shout outs here. True Helper as well in the chat with us. Want to thank everybody once again for tuning in tonight. We felt like we've had some issues throughout the last couple of weeks with some of our programming. So we're trying to work out all kinks that we might have tonight, just testing out a couple things, and thought we'd do it while we had a live chat going as well, watching a few of our produced videos and plus other important videos that we feel is necessary to be a part of your grand solar minimum education. Most of you already have a pretty good grasp and understanding on what's happening right now, but unfortunately there's a lot of you out there that may not still have access to the correct information. So this is something that Mari and I maybe will start doing a little bit more often, where we're going to share these playlists of videos that we feel like is important to the community and help maybe put some clarity on the situation and the subject itself. All right, guys, we'll get you back to programming. I just wanted to jump on and say hello, and Waylon says hello as well. Thank you, Waylon. Anything else? How's the weather looking, Waylon? Not too good. He's growling. So with that being said, we'll go ahead and get you set right back up over the videos here. Guys, thanks for tuning in once again. I'll see you all in the chat here in a little bit.
Thank you for tuning in to the Grand Solar Minimum channel. Today I would like to discuss 3 of the main solar cycles that we discuss on this channel. There are regular solar cycles, grand solar cycles, and super grand solar cycles. First off, let's explain a solar cycle. The poles of the sun's magnetic field change places each 11-year activity cycle. The north pole becomes the south magnetic pole and vice versa. Thus, the 11-year cycle of the sunspot frequency is actually half of a 22-year solar cycle in which the magnetic field reverses itself repeatedly. Actually, the length of the activity cycle is not exactly 11 years. That's just an average value. Sunspots are regions where the solar magnetic field is very strong. In visible light, sunspots appear darker than their surroundings because they're a few thousand degrees cooler than their surroundings. Near the minimum of a solar cycle, it is rare to see sunspots on the sun, and the spots that do appear are small and short-lived. During the solar maximum, there will be sunspots very visible on the sun almost all the time, and some of those spots will be very large and last several weeks. So we have this 11-year cycle of sunspot frequency. It goes back and forth from maximum to minimum as the magnetic field changes. So what is a grand solar minimum? Well, a grand solar minimum occurs when several of these solar cycles exhibit a lesser than average activity for decades or even centuries. Solar cycles will still occur within these grand minimum periods, but at a lower intensity than usual. There has been a lot of correlation with global and climate changes with grand solar minimums. We'll get into that on another video. So what is a super grand solar minimum? In Valentina Zarkova's recent paper, Oscillations of the Baseline of Solar Magnetic Field and Solar Radiance on a Millennial Timescale, she describes a super grand cycle. Let's take a look at the chart in Figure 2 in her paper. Breaking it down in the most basic way possible, looking at this chart, you will see all the solar cycles in a 20,000-year summary curve. There's grand cycles of 350 to 400 years of solar activity. There are also indications of super grand cycles marked by the vertical lines on the graph. These black lines, if you look at them very clearly, in each block between these black lines, you will see 5 grand solar minimums. So super grand solar minimums are 2,000-year blocks approximately of even lower solar activity. These solar cycles again are approximately 2,000 to 2,100 years. The minimum of the current super grand solar minimum started around the time right before the Maunder grand minimum. If you go back in history, you will see how prolonged and long that grand minimum was. There's a lot of confusion, and I wanted to make this video specifically to explain to people there are many different cycles, some that overlap, and it can get very confusing. I plan on doing more short videos like this to explain the more technical information in a very layman's way. Hopefully this clarifies the difference between regular solar cycles, grand solar cycles, and super grand cycles. Thank you for tuning into the Grand Solar Minimum channel. Please like and share.
Today we have a very special guest with us, Dr. Valentina Zarkova. She is a professor of mathematics at Northumbria University, also a PhD in astrophysics. A recent paper that she has had published in nature.com as of June 24th, 2019, Oscillations of the Baseline of Solar Magnetic Field and Solar Irradiance on a Millennial Timescale. Valentina, how are you today?
I'm doing very well, thank you.
Great to have you on. I know you and Mari have had several conversations dealing with this paper, and so today we thought we'd bring you on and once and for all kind of explain a bit about the paper. And there seems to be a little bit of confusion out there, not from this side. We are totally clear on what's going on here. So basically, if you wouldn't mind, I guess we could just start and talk a little bit about the process. You came out with the presentation in October. This was a long process, as is the peer-reviewed journals are. But if you could just kind of take us back to how things kind of started and got to where we are right now with the paper.
Yeah, first of all, can I tell you that I wasn't so busy with the paper, but with the exam board and marking, finishing, and doing evaluation of my modules. Only now I'm getting towards the paper because it will be reported next week on the National Astronomy meeting. So this is why we eventually prepared the press release, and hopefully it will be going out either tomorrow or Monday on our side and the Royal Astronomical Society side. So we're working on it, and so this is what I started doing. And of course, I was involved with this unexpected, because we didn't have press releases. I thought people wouldn't see yet the paper, but it turned out some people read the journal much more extensively. And so obviously I got involved in some interviews. Actually, it was radio from Manchester who got me on Tuesday even.
I heard that.
Guys.
I heard that. Very good interview there.
Yeah, it was a very good guy, actually. And he interviewed Akasofu. He knew the problem. So obviously it's not only us who understand the problem, there are many others. So definitely this is the happening. So it's nice to consolidate alike people. I really was pleased to speak to the person, I had to say.
So let's get right into it, I guess. First subject I wanted to talk to you about was the super grand solar minimum cycles. I think a lot of folks might have misinterpreted what exactly the definition of the super grand solar minimum. So if you could just kind of tell us about these super grand solar minimum cycles and how this came about.
Okay, so let me explain that the solar activity, this is something which is happening on the sun. And what we done in the previous paper, we detected these double dynamo waves which interfere and produce this grand minimum every 370, 400 years. So this is fine. This is what happened on the sun. on the way, while we're working on this, we managed to derive the formula for these waves. So this makes our life much easier, because now we can calculate this wave as long as we wish. And in the last half year, we calculated it backwards to 120,000 years. So, and when we did it, we discovered that when you look at the summary curve which describes solar activity on the sun, there are patterns which repeat every 5 grand cycles. So every 5 grand cycles we have first cycle slightly higher amplitude, narrower cycle. Second cycle amplitude lower, cycle wider. The third cycle has something also particular. And when you produce this for 20,000 years, you see how you can split them into particular parts,
Okay.
combining 5 cycles, which the shapes repeating each other. So this is the first visual view at this cycle, which really surprised us all. So we thought, oh, what is going on? So we get this 120,000 years of data. So we decided first to see what is this cycle. At that time, it was visual definition, about 2,000 cycle. Can we find anything on the sun? And we couldn't find anything on the sun. Sun works with 2 dynamo restlessly for billion years and nothing else. So I thought, where this nice pattern comes from? Because when you look at the paper on the, I think it is the figure 2, upper figure 2, the red curve, which shows you nice patterns with the 5 repetitions, and they look very, very similar. If you look at your screen, we put vertical lines to show how similar they are. So it's visually, but when you see them visually, of course, people would not believe you that you see the same pattern. They say you're making it up. You built specifically this curve to show us pattern. So this is why we started doing statistical analysis of the data. We started blind filter, trying to get this pattern 2,000 years. So we needed to run the filter about 1,000 years to suppress all other oscillations of the 11-year cycle, because the amplitude is biggest. So we wanted to suppress. When you run 1,000 year, it becomes very average magnetic field. And we also played with the 20,000 year filter. So you again suppress all the oscillations. And when you're playing with 20,000 year filter, we discovered this 40,000 year oscillation already seen in our curve between 6. It is figure 1 bottom, which shows you 40,000 years cycle, which is actually, it is the cycle, Milankovitch cycle, because of the Earth's obliquity.
Yes.
So the Earth's orbit is inclined towards the ecliptic. Now it's 23.5 degrees, but it varies 22 to 24.5. And we discovered that indeed we see in our curve this change of obliquity within 40,000. The period is, Milankovitch says, he calculated 41,000 years, and we see it in our curve. Suddenly this clicked that, oh, obviously our curve has not only solar activity, but because we observe this activity from the Earth, Wilcox Solar Observatory is based on the Earth at Stanford. So obviously we cannot avoid orbital motion effect on this. So we said, oh, what can we see? Maybe these 5 cycles repeating each other, maybe this will be another orbital effect. So this is what we played with the filter about 1,000, and we discovered this very clearly. The cycle of about 1,150 plus minus 95. So we say 2,000, 2,100 100 years, which came with very high accuracy. So really surprisingly, for all 120,000 years, we got this cycle oscillations, but the magnitude, of course, of these oscillations were by order or even 1.5 order of magnitude lower than oscillation of the summary curve of magnetic field during normal cycles, because it includes solar activity with the big numbers. But when we suppress these big numbers, we discover these oscillations, which is basically of the zero line of magnetic field. So like if you have cosine function, cosine goes from 0 to 1, and then from 0 to -1, and zero line is when y equals 0. In our case, this y equals 0 turned out to be also a little bit fluctuating curve. So it is not exactly straight line, it is like slightly waving.
Right.
So this is what we discovered, that this zero line like trembling, but it trembled in very organized order within period 2,000 years. So at that stage, we of course be very puzzled and started looking what people had, because people are very smart and they already probably look at something. They couldn't explain it properly, but they had intuitive perception they should be right.
Right.
And we found this solar inertial motion, which was very actively promoted by Karvatova from Czech Republic, from Ondřeje, in 80s, 90s, even 2005. She still published, probably now she retired. Before that, in 70s, it was Fairbridge and other guys who we cited in the paper. They first calculated this solar motion, that it turned out that our sun, would they tell us the story about solar system, how it was formed, and the sun sitting in the focus of the ellipse and planets rotate around it in the same ecliptics. It is a nice story for children. In reality, it doesn't, everything doesn't look like it seems. Because first of all, the planets are rotating with some angular inclination to this ecliptic. So what is for us ecliptics, maybe not the same for Mars or some other small angles, 5-3 degrees and so on. Plus what it makes, the large planets, so they somehow rotate, they made the sun so move around the very center of the solar system. So it turns out, because of this deviation of the orbits from the classic ellipses and so on, that large planets impose that the center of solar system is slightly offset from the center of the sun. So the sun is a little bit, can coincide, but can be up to 2 solar diameters away from the center. So basically it moves on the cycle about 2 solar diameters towards in different part orbits, basically rotates around this barycenter. And so do the planets. So they pretend they rotate around the sun, but what the planets do, they basically rotate around the barycenter as well. And this is what creates a little bit confusion.
Okay.
And it turned out that this is the only effect which can explain possibly this 2000 cycle, because Karvatova and then Palush, he was also working in Czech Republic. They calculated exactly profiles, plus the guys from Australia, whom I cited, and the Kornus calculation, it was their calculation, orbital motion. So it captures many minds. So basically they calculated that indeed the planets make the sun move, not simple in straight line, it just rotates in some like spiral rotation, like we shown in figure 4 in our paper. And because of this one, basically what Sun does, if this orbit of the Earth is ecliptical and it should sit in the one of the focuses of the ellipse, the Sun cannot sit there. It starts moving either closer to apohelium or closer to perihelion. If it moves closer to apohelium, the Earth's orbit becomes more circular, which means that magnetic field become higher because the Earth moves slower in the apohelium and the spring and autumn equinoxes, and much faster during the perihelium. So this is why we have increased, slight increase. It's only, I don't know, even you can say 1% or 2%, but it's essential that we have slight increase of this magnetic field because of this motion. And then when it moves in some other periods, moves away from apohelium, close to perihelium, the orbit become much more ecliptical, which means that we have much smaller magnetic field because this Sun mostly sitting in the focus of the ellipse, and because the main part of orbit of the Earth is far away from the Sun, so the magnetic field is decreased. So this is basically was the, I think, eureka moment for us, because what they said that this imposes the period about 2,100, some say 2,400 years, period of rotation of the solar inertial motion of the planets around the Sun. We got only maximum 2,100, but maybe if you include quadruple components, maybe we will expand it bigger. We don't know yet. At the moment, as you know, our summary curve is based on the dipole magnetic waves produced by solar dipole. So this was explanation. So basically what this paper says, everything which was said about double dynamo is correct, is happening on the Sun, it's beyond our control, it's always happening, and we always have this grand minima every 370 years or 400 years, they will be happening. But on top of this, we can avoid, we can remove ourselves that we are sitting in the Earth which orbiting around the Sun, and planets are orbiting around the Sun. And they all telling the Sun what it needs to do. And this is reflected on this fluctuation of the zero line. So these are two effects which add together. And nothing we can do about it. We need only to embrace both of them, unless we are planning to nuke large planets and remove them from the orbits.
Right.
This is it.
And you know, and the reason why I led off with that concern of the 2,000-year cycle, I think there's a lot of people that misinterpreted it. The 350 to 400 years, the grand cycles, there's 5 of them in these 2,000-year super grand solar minimum cycles. I think some people were actually confusing the term as if it was going to be a much more intense grand solar minimum, a much colder grand solar minimum. People took that word super and thought that it was being referred to the intensity of this particular grand solar minimum, not that it was measured on a 2,000-year time scale. So that's kind of the reason why I wanted to put that out there, to really clarify for people who may not
The word super is related to the length of this cycle, not to its amplitude, to this increase, because grand cycle obviously has much stronger waves, much stronger activity, because it is real activity, 11-year-old, we can't avoid it, while this 2000 will have tiny few percent of the amplitude of the grand cycle, but it is essential because the Sun physically moves closer to us and further, it affects our temperature. This is essential why we brought it up.
To clarify for the viewers that had some confusion about whether or not we're going into a super grand minimum or a grand minimum, my explanation to them, and I'm hoping I'm reading your paper right, is that the super grand minimum, the bottom out of that was right before the Maunder minimum, and we are coming up out of that, and that is causing that temperature increase.
Yeah, it was a very drop during the Maunder minimum because it was coincidence. It was grand minimum at the same time, and it was super grand minimum. So orbital motion of the Earth and Sun coincided with the minimum in the solar interior by dynamo. So
Right.
the two coincided. This is why this minimum was so extended and so intense. Will not have for next to 1,100 years, luckily, and maybe the next grand minimum will not coincide with the minimum of these super grand cycles. So we will see.
And Mari makes a excellent point there, because my next concern that I wanted to address is so many people are focused on that warming that we talk about in your paper, the 0.5 degrees Celsius every 100 years, and altogether maybe 2.5 to 3 degrees over the next 600 years. That's all natural. There's nothing in your paper
Absolutely. And done by Akasofu. He was the director of the Space Institute in Alaska, and he published paper 2010, and they crucified him. They couldn't find the reason why would the temperature increase, but he was right. It is increasing. He didn't know the reason, and I'm glad to be able to give him the reason. He retired, but he's still there. Maybe he would read it and he will understand, yes, he was right. And the reason is because the sun moves physically closer to the Earth, makes our orbit more circular.
Right. It will also be a little bit further from the sun. Is that correct? How I read that in the northern hemisphere?
Again, if it is ellipse, so if it is ellipse, your sun is not in the center, but in the focus of the ellipse, one of the focus. So the focus which is closest distance of the orbit is perihelion, when we have winter in the north. And if the sun is closer to perihelion, or perihelion, in perihelion and even closer, it means that we will have colder winter, because basically we will have less, the sun will not be close enough, will be cold. But if the sun moves closer to apohelium, it moves closer to the center of the ellipse, not to the focus. It means that in the apohelium, the sun will be closer to us, and we will have much hotter summers in the north, while Australia, southern hemisphere, will have much hotter, warmer winters, because they will be closer to the sun in this July period.
Right.
Yeah, while when we move to the December, the sun is still there. It doesn't move so quickly. It needs 2,000 years for it to move. So the sun's still closer to apohelion, so which means that it is further from the nearest point. So in 21st of December, sun is further from the Earth when it would be when it is sitting in perihelion. So basically making the Earth's eccentricity nearly equal to zero, moving to the center, which makes our winters colder, because it is further from the Earth in the winter solstice.
And it's amazing to me that there are some people who actually are more concerned and focused about the warming over 600 years, when we've got to worry about what's getting ready to happen in the next 30 years. And nowhere in the paper, from where I read, does it say anything about warming temperatures in the next 3 decades. So we're looking at the grand solar. And by the way, when we had you on our program 2 years ago, I flat out asked you, are we heading into a grand solar minimum? You answered yes. today, as we speak, this paper confirms indeed 2020 begins the grand solar minimum period. And so for me, I think what I'm gathering from this paper the most is that we are getting ready to enter in some challenging times. We are going to see colder winters. We're going to see shorter growth. We're already, I mean, we're witnessing these shorter growth seasons right now. And I keep hearing from people, it's only going to get worse because this is only the tip of the iceberg, no pun intended. But this is only the beginning of these conditions that we're getting ready to embark for the next 30 years. So I applaud your work because it's able to look at both sides of the natural cycles, the warming and the cooling. But anything in this paper, to me, I'm taking is a huge red flag and a warning that we have to adapt and we have to get ready for some challenges here in the next several decades.
Yes, you're absolutely right. Moreover, what in this paper we wanted to say, the Earth is capable to absorb the increase of the temperature, another 253 Celsius, and doesn't disappear. It keeps rotating where it is. Everything on the Earth keep living because it done in the previous 120,000 years, had 60 of those cycles, no ever human interaction, and it managed to survive. So this is the thing. It's not so dangerous to have increase of the temperature. We cannot, if we cannot do anything, then we embrace it and we prepare for it. So this is what my one of the conclusions. So it is not that scary. I don't know if it is. I'm not discussing this global warming human induced, but what I'm saying that the nature has the mechanisms how to handle it, and it been handled because the solar system exists about 4.5 billion years, so we're still there. So it is obviously handling it okay. Of course, our first problem, most essential problem in the next 30 years will be this grand minimum, because indeed, as you correctly said, growing period is very damaged, very reduced. So obviously northern parts, northern latitude, there will be a shortage of some vegetables, fruits, some food for animals and so on, and it will be worsening with every year.
It's going to trickle down, yep.
Yes, and this is why, I don't know how it is in your part of the world, but I had heating yesterday in my house because it was very cold, and it is end of June. I never had it before in my life. It was pretty warm, but now it is not so warm. So obviously it is cooling off. So I don't know who, but what I was trying to say that despite this cooling off, there will be still increase of the temperature because the sun is moving closer to us during the summer. So we might have warmer summer in the next years because simply it become closer. What it says that we mostly dependent on the solar energy and the solar irradiance.
Right.
So it is the main source of our lives, and I'm doubt very much. I don't know. As I said, I will not be advocating the planetary science. People have enough said in the different conferences about CO2 and other, but definitely what we see from the point of view, the system, sun and earth, they worked out very good relationship, and they support each other and survive for billion years.
You know, I've heard several forecasts for the next upcoming solar cycle. There are people out there who actually have forecasted lower solar activity, but still admit that, or they believe that human activity has more to do with the climate. And I really don't want to get into that whole debate because that's right now, it's kind of one of those things that it's almost like politics. You don't like talking about it. But I know my understanding is that CO2 does not affect temperatures. And I think that's one of the biggest misconceptions of our time when you talk about the scientific part of climate. I guess the hope is papers like this will help connect the dots for other people out there. And I think here lately, we've seen a lot more mainstream. I've noticed. I know Australia Sky News, they're starting to mention a little bit more about how CO2 is a trace gas. There's a few rumblings here in the States. We're starting to talk about it a little bit more. And I think when people like you, such as your wonderful brain has presented us this work, I think more people like you will be able to help society accept what's coming. And I guess what I'm trying to say is that it won't be so absurd to think, because so many years we've been taught that CO2 causes warming and human activity affects the climate, and that we're just going to burn up as a planet. And if we don't stop emissions, then in 12 years, then we're going to die, or whatever the claim might be. And again, I guess what I'm saying is my appreciation for your work and what you're trying to explain to folks. It has nothing to do about being a whistleblower. This is just you applying your mathematics to your research field, and this is what, and it works. I mean, the spoiler moment, the spoiler minimum. I mean, you've explained already that you believe, and I think a lot of people agree with you, that supernova was the reason why we experienced minimum conditions.
Yes, and it was only one cycle which went out, and actually for the same period, remember we put in the paper, the observations of the temperature during spur minimum show it was a maximum, while it should be minimum. During the minimum of the activity, we know the temperature decreases because solar activity decreased. And so this is very straightforward relationship. It decreased not much, a few percent, but still it should be decreasing, while what they measured, it was increased. So it's another issue, but coincidence with many other grand minima, Wolf, Hammer, Maunder, and others, when you look backwards, even the curve which was produced by Solanke in some cases, in many cases we have very similar. When they put the proper background of the cosmic rays, they hit the same grand minima as we did. So obviously we're walking in the right direction, and they walking. Of course, they're affected by the background, which they don't know what was 2,000 years ago or 800. So this, I understand they have the problem. But the thing about this current paper, it is not only explains that these oscillations come from solar inertial motion, what it explains that increase of the temperature by itself is not a big deal for the Earth. It can increase by 2-3 degrees, because it's already increased by 0.8 degrees from around the minimum. So, and another 2.5, it will be definitely 3.5 degrees by 2,600. And because we had about 60 of these super grand cycles in the past 120,000 years, the Earth survived pretty nicely. We don't have any records of, during the Roman Empire, any cataclysm or other. We remember that during Roman Empire, they grew grapes in Scotland, where it's cold and wet now. So at that time, it was pretty warm. So it probably explained that, no, you can adopt, and it will be nice and warm. So what? It will be probably higher sea level, but after that, everything will come back as it was before. So the Earth is stable, but dynamic system. So not everything just set up on this same level. And I would be very surprised that the planets are so vulnerable that the tiny amount, which is not detectable even, according to these planetary people whom I read, Professor Salby from, which is Imperial College, and some, it was a conference in Portugal, the people showing different examples, and they sent me the papers proving that it could not be increased. So I trust they're doing proper job. They simply cannot get enough audience to believe to them. But from the general common sense, I would be very worried that the Earth would be so vulnerable that this tiny amount, which we cannot even trace properly, suddenly would send the Earth to the, absolutely disaster. If it was so easier, it will be indeed, the Earth would disappear in the previous 4 billion years, but it didn't. And this tells you that something wrong in this conception. And if you look at the paper by the same Akasofu, figure 9, they show how the people from IPCC extrapolated the temperature increase, and they used the linear extrapolation of the curve, which basically is Doppler curve, has maximum. So you cannot do this interpolation this way, and this is why the increase was 3 degrees, and they start scaremongering and so on. So what I'm saying, that even if we accept, and we know now that the temperature will increase by 3 degrees by 2600, but nothing dramatic will happen because we had this before.
Yep.
We just need to do something else, and this will be fine. This is the point of this.
And that's what I love about this paper, the honesty of both sides of this. There's nothing, you're not trying to support an ice age agenda. You're not trying to do any of that. You're showing us where we could run into a lot colder. And I believe you said that the next minima, grand minima, the 2020 through 2025, is going to be similar temperatures around the modern minimum type.
Yeah.
So, I mean, again, 0.5 degrees in 100 years is not that much increase. And if we look at the data on all these charts, I mean, we've got people arguing about 30 years of information. And the minute we zoom out and look at the 100 years, the 1,000 years, and 2,000 years, then they get upset, because that shows, the big picture shows us that we are on a steady, not a skyrocket warming or diving.
Absolutely,
cooling.
we are on steady fluctuations.
Yep.
Also, when I may return to this grand minimum, when we predicted it, when we said that the sun has steady waves coming again steadily in its interior, one at the bottom of Tucker line and one close to the surface, and only their interaction changes, so we see different sunspot numbers on the surface. This was a big problem for many people who did different dynamo simulations, because somehow they came up with the idea that the sun is stochastic. So it doesn't have strict rule. It just produces the waves, stochastically. Woke up, okay, today I'm in bad mood, let's produce some sunspot. And then after that I'll go to sleep, I will not produce. No, if this was the case, then if sun was stochastic, then it would be on its last legs to the explosion. Normally all celestial bodies, like human body, they like some steady process. So the human body, if the person had heartbeat with a tachycardia, which is stochastic, so this person is about to die within a short time if he doesn't have stem or something in the heart. The same is with the sun. So what our model explained, that there's no stochasticity. The sun works like hydrogen atom. It produces these waves on the regular basis. The only difference that these waves have slightly offset amplitude and slightly offset the frequencies. And because the waves are interfere with each other, so you have either constructive interference where amplitude increases during solar maxima, or you have destructive interference where waves suppress each other and amplitude comes to the zero. And this is what, because the waves are of phase, so they periodically, they run into each other every 3,700 years, they come into destructive interference. But it doesn't mean that something changed in the solar interior. Sun even probably doesn't know what is happening on its surface. It producing these regular waves, like hydrogen atom producing this emission in the atom. They sit in this wave function, electron sitting on its orbit, and they never change. This is what basically was main outcome of the first paper, that we remove stochasticity. Of course, there are some elements stochasticity because something changing the properties of the media where these big loops propagate,
Right.
which becomes later sunspot. And this is indeed needs to be investigated. But after we sort it out that the sun is steady producing these waves, it's much easier to live. We can be confident that it will survive another 5 billion years before it is predicted to explode as another supernova.
Mari, did you
Very
want to?
interesting. Actually, yeah, it's the grasping of these cycles for people who aren't well versed with the science behind it. You have your super grand minimum cycle, your grand minimum cycle. You stated that the super grand minimum bottomed out right before the Maunder minimum. We are going into a grand solar minimum that is you're forecasting to be at Maunder level conditions. How do you think the effect of not being in a super grand minimum do you think that'll make it easier? Looking back on history, all the troubles and woes, I mean, we still are facing some major issues, but is it possible to say that since we're not going to be in a super grand solar minimum that we won't be as troubled as people were in the 1600s, but we will have more so concerns with societal issues with food supply and that kind of stuff? Do it make sense?
I believe we will have, it's a good question. I believe we will have slightly less temperature decrease in the current modern grand minimum compared to Maunder. Because at the Maunder, we were at the bottom of everything, bottom super grand cycle. Temperature was 0.8 degrees lower, so everything was a little bit cooler. So with the upcoming grand minimum, we will have slightly higher temperature from which we start from. So definitely decrease of temperature because solar activity stopped.
Right.
Will be slightly less because we already have this gained extra increase, so we have something to lose, which will be easier for us. And furthermore, this grand minimum, which upcoming, will last only 3 cycles, while Maunder lasts for 6 cycles. So we have less time to struggle, which again, very good for us, so we can cope easier and survive everything with the modern technologies, heating and food processing. The problem will be, of course, to provide the food, and probably standard usual resources, growing potato in Great Britain maybe will not be acceptable. You need to grow them further south. And what my talk with the Manchester guy actually raised the question. I said that I've been informed that African countries are preparing actually to grand minimum much better than Europe. Because why they're preparing much better? Because they had snow first time in 150 years since they become measured in the last year. And they were asking me, Al Jazeera, I had a chat with them. I said, it is. I said, yeah, this is coming and you will have more. So they realize it will be cold. But what they realize, there will be much warmer in Africa than up the north in all the northern countries. So they're preparing, African country preparing the agriculture. So they start feeding northern countries and make a huge profit from it. And the guy from radio said they also had information that Chinese people, they're very entrepreneurial, they buy in actual lands and properties in Africa because of it. So obviously people listening what we are
Yes.
saying, not necessarily Western governments,
No.
but those entrepreneurial people, they know their time will come and we have no choice to pay. If we want to have potato, broccoli, we need to ask African country to deliver it because it might not grow up, if not this cycle, but definitely the following cycle, 26 from 2030. This will be the worst period. This is when we will be probably begging Africa, Mexico, and others to provide the food. And at that time, I guess the wall in America will work against you because
Right.
you will be
Oh no.
begging Mexican
Oh no.
vendors to-
And you bring up a good point because some of these other countries are more prepared for this type of event. And you hit the nail on the head. The Western government is not prepared. In fact, when you have lawmakers in our government, rules that will make it more expensive for energy, a lot harder to be able to afford food with just all the politics that's involved with this situation. Our lawmakers will take the money that we are spending our taxes on, and where we could use it for infrastructure repairs or maybe indoor grow facilities or whatnot. I'm afraid that there will be lawmakers that will take our money and invest it in things that are supposed to be stopping this, but it won't work, and it'll be a waste of money. I'd rather put a bunch of money into something that could benefit us in the next 20, 30 years instead of fighting a fake battle with a trace gas. So I worry about that here in the United States. And it's interesting to hear you talk about Africa, because when I first started doing this research, a person I was very close to actually was talking about a possibility for us to be getting food. So you're echoing the same thing that I've heard as well from a trusted source.
Yeah.
So it kind of just, gave me one of those, I remember hearing about this. So it's not unheard of for the idea of Mexico or Africa. And I guess that brings me to my next comment, which would be we need to get our acts together and try to find a way to work together, because countries like that, if we're going to have to depend on them for our food production, we really need to start playing a lot nicer with everybody.
Absolutely. We need to be nice to our southern neighbors,
Yep.
that's for sure.
Yep.
Because this is what Earth and Sun teaches the humankind. Be nice to each other, and don't break with your neighbors.
That's right.
Because you might come and beg into them for something.
So true. We hope that it doesn't come to that. We hope that we never have to worry about our neighbors knocking on the door because of how bad things could get. But you're right. We need to be prepared for that. And there's a lot of mentality out there that's, the strongest will survive. Well, that's true to a point, but we also have to unite and help each other. Like you said, the earth has gone through this many, many, many times. It's survived. Nothing cataclysmic happened. We as humans, we will find ways to modify and adapt and, move forward and progress as a species. But with what we have in the near future, we have to get serious, because that could turn into other problems than just weather issues. We could
Yes,
deal with
exactly.
famine, disease, economy issues. There's so
Absolutely.
many things that are riding on this, and it's important that we all get the information straight and work together.
Yeah, we need to embrace what we cannot change. We can change what we can, but we need to embrace what we cannot change and adapt to it. And this is the point what I was trying to make. Of course, I could leave it, unpublished and everything, and they were saying, reduce the temperature 1.5 Celsius, and then when it will be increasing, that we didn't reduce it, and the earth will erupt or explode. What I'm saying, no, it will not explode. It will last very happily after, with increase up to 3 Celsius, because it had it before.
Right.
It will come in and will go. So this is actually puts back in perspective this scaremongering which comes from the panel saying that it will be too hot and everything.
Right.
They say it will be even hotter and nothing will happen. So basically, playing it around that the temperature will be increasing independently of the heating by humans.
Right.
So this is important point. It's not simple that I'm saying this what I'm just delivering. That Earth survived this, and it had many hundreds of those before. So now they need. No, heating does exist. Indeed, we don't object it, but it comes not from the source what they're saying.
Right. That's the biggest part. It's natural, just like the cooling. It's natural.
Yes. It's natural.
And people need to understand too, once we reach that 2.5 to 3 degree mark at 2600, that's when we'll also start to witness a decreasing of the magnetic field once again. So again, we're cooling and we're warming and we're cooling and we're warming. And I'm really glad we had a chance to talk today, because I think there was a lot of for some reason there was some misunderstanding statements about this. I don't see how, but they're out there. And I think you of clarifying what we have in front of us in the next 30 years. Do you have time to answer a quick question about pole shifts? I know that's may not be something that you're well versed on, or maybe you are, but we have a question from one of our subscribers. And if you don't want to answer it, that's completely fine. We can edit this out completely. But he asked if the changes in the magnetic field of the sun can have an influence on the pole shift that's also happening. So they're wondering about the magnetic pole shift here on Earth. What's happening with our sun right now? Could that have an effect as well with our magnetic pole shift here?
Possibly. I don't know. I never investigated this problem, but I can the thinking aloud would to say, when the solar magnetic field is decreased during the grand minimum, so this is the essential effect for the whole solar system. We had the shield, solar magnetic field, which protects us from cosmic rays, from anything. Then this magnetic field will decrease for the next 33 years. Obviously, we will have huge invasion of cosmic rays coming from anywhere because nothing protects. But it also shows the magnetic field in the planets, which was previously suppressed by the magnetic field of the sun. This suppression will be gone. So what the planets will do with this, we don't know. We will watch it in the next 30 years. I'm very curious to see what is going on, what will be happening. But I'm sure it has to be something different than it was before when magnetic field was strong.
Right.
So this is the key point.
And then that has a domino effect on all other Earth systems, whether it's volcanoes, ocean oscillations, the jet stream, everything. It's such, I think that's the hardest thing for us reporting news on the Grand Solar Minimum channel is it's such a broad area to cover. There's so many different puzzles to put together, pieces of the puzzle to put together to understand what's going on with our climate, and everything sort of is interlinked together. So for us to actually truly know 100% what's going on, you would need a whole team of people with their different specialties. You have like Svensmark with this cloud project. There's groups on like SPACEWEATHER.com, the Earth Sky, that does
Dr. Tony Phillips
does cosmic ray.
Yes, I will send you the links to this paper for this conference, which was in Portugal, which planetary people came together and spoke about temperature, carbon, and so on. But probably most relevant to understand what is the effect done by the planet, El Nino, and different parts. Knowing what the sun is doing you can discuss with them how the Earth responding what the Sun is doing. So you can discuss with this. And then you, of course, you know the talk by Murray Selby, who explained that there was another guy also in Canada who tells that carbon dioxide, the quantity of carbon dioxide is not detectable. The quantity produced by human is so little that it is not detectable on the background of the general quantity. And carbon dioxide is not all bad, because
Not
all
at all.
our trees live on the carbon dioxide. So the more we breathe, the more trees will be growing. Put more trees, it will be perfect.
And that's proven. NASA's shown us maps and satellite imagery that the Earth is greener.
Yeah, NASA is big on that this year and last year about how CO2 is the main cause CO2 is doing right now is greening our planet. You brought up the atmosphere and how small. On Sky News, they did a demonstration. This lady, they poured a bag of rice into a bowl, and the news commentator grabbed just 1 grain of rice and put it on the desk and said that's how much CO2 that Australians are putting in the atmosphere. The whole bowl of rice was the atmosphere, and that 1 little grain of rice was exactly the emissions. So when I hear people say that human activity has more to do with our climate, I would have to say that that's a little bit false, and I understand that there's people who learned a certain way, but it's just hard for me to look at them as a scientist anymore when they want to try to lie to people and tell them. Yeah, so honestly.
You look at the same happening on Mars. The same, we have polar caps on the Mars are melting at the same time like our Arctic is melting.
Right.
And who is melting them?
Who's driving the SUVs over there?
Yeah.
Yeah.
Or
It's the Mars rover.
It has typhoons now. It never had before. It means that its atmosphere is heating as well in Jupiter. Look at this. When you look at other planets, you immediately recognize that we are not capable of doing this. It has to be someone bigger than us. And the only person or subject bigger than us is Sun. Nobody else can do. And this is why we cannot take everything that humankind does. Yes, probably pollution with the bad materials is not good. Maybe we need to reduce pollution because people growing up, having cancer, having different diseases, this would be nice to make it cleaner. I don't mind. This is good thing. But to assign that the whole humankind and all our industries and all our heating producing this CO2 and planet is literally on the verge of to explode in the next couple of decades, this is a strong exaggeration. I'm just appalled.
You echo exactly what we believe here at the Grand Solar Minute. We agree that we could do a better job at making cleaner air to breathe, cleaner drinking water. We do believe that we do have influences on that. But when it comes to climate, when the information is just all wrong when it comes to telling people that it's your car that's causing global warming or sea rise or anything like that. Mara, did you have anything else that you would like to ask Dr. Zarkova before we wrap it up?
I asked people on Twitter if they had any questions. So would you mind if I asked you a few of their questions?
Yeah, please.
Okay. When I asked people on Twitter, what kind of questions do you have for Valentina? A lot of people asked about climatic stuff, like you're a climatologist, and people don't understand. You don't have that kind of meteorological, I can't say that word, meteorological training on that. You are studying the most important aspect of these calculations that everyone's trying to puzzle piece together, and that is the sun. That's where you are providing answers to in this big puzzle of different pieces that everyone's trying to assemble. So, you know, it is
I
what it
came
is.
to climatology absolutely randomly. I was investigating the sun. We had a European project where we done nice automated pattern recognition, a lot of nice data extracted from digital images. So what we done, I was leading the group which is doing this in the digital era. You're trying to bring the proper methods and computers into all the science. So you're not drawing like people before sunspots and counting by hands. I said, okay, we passed the era of drawing. Let's do this computer. So we produced terrific solar feature catalogs and produced the sunspot for the cycle 23. And this is how I got into this subject. So we got these catalogs and we started thinking, okay, we can give it to other people to analyze them, or we can analyze them ourselves. So this is how I started learning what people did before, because I am actually a plasma physicist, theoretical physicist.
Right.
And I'm mostly better, I do high energy particles. I have papers in Nature for discovering sun quakes, or recently with my PhD students about H-alpha emission. This is why I know hydrogen atom, how it works. So this is my main specialty. But to get into the solar activity, it was as a like tail from this big European project, which I didn't want to leave to someone just to pick up flavor of. And this is how we got into it. Even when we done the first paper, I did not realize what effect it will have on the whole status of the climate change, because I didn't realize that these people from IPCC start attacking me personally, like I'm trying to do something with their science. I said, look, I don't do your science, this solar physics. But somehow it turned out they're strongly interrelated. So they dragged me in. And this when I started since then, looking in all this other research in planetary stuff and others. People started sending me their research, sending me the links. So last 4 years was a huge learning curve for me. So I'm getting into the climatology slowly, and not necessarily willingly, but I had no choice. Because this is what I discovered, that I can tell people that increase of the temperature by itself is not a big deal. The Earth had it before.
Yes.
And it is still here. So we need to find something else for these guys. And this what up to them to find for time being.
I'm excited to see people take your paper and do their own research in their own specialties based on the data that you
And
have.
apply it.
Because I think once they apply your calculations with a new perspective, we're going to see some really interesting papers that reference yours from this. It's huge.
I would suggest some people should use the magnetic field data from other observatories. I simply don't, they ask, why don't you do this? I physically don't have time. I teach different modules.
Right.
I have projects funded by US Air Force to investigate high energy particles and magnetic connection in them. And we are on this second year of this project, and I work with my postdoc, and I have PhD students. So basically, I'm really tied up, and I have family, of course, my granddaughter, son, and all family. So basically, my time is very limited. So
Sounds
with
like
this limited time, we squeeze free time, not paid whatsoever, apart from donations, and do this research out of curiosity.
Wow.
But that's how we are, though. I mean, I relate to that. It's so time-consuming.
Pushing down, nailing that you haven't done. I become, the more you nail, the law, the more you push, the more is resistance. So this is what I'm working, straight on the physics law.
Wow.
I can imagine how busy she is. We really appreciate the time that you have given us with this interview. I'm excited to be able to help you with your website. We're working on that. I've told people about that. So,
Fantastic.
We're hashing out the technical aspects of that. I'm excited that you are willing to take this time that you're not getting paid for or anything just to help educate people and have
Yes.
people get a grasp on to what
Yes.
is going on. So
Exactly.
I'm excited for your website, and I really would like to
Thank
encourage
you.
our viewers to, if you can donate to Valentina, please do. And I'll put the links to everything
Thank
on the
you very
website
much.
in the description. She deserves it. Like,
Absolutely.
there's so many channels asking for this and that. You know, there's people with fundraisers everywhere. Let's pool the money to people who make a difference,
Yes.
like Valentina,
Absolutely.
because
Yes.
I really respect your work.
Full time for me, not when I find the time. Then this person could do, like my postdoc, he works his paid salary. So even if I speak here, he's still doing his talk. He has also talk at NAM and everything. He needs to do it, and he needs to work on his CV to get the job. So this is working. But my part in this, I need to find my spare time. I need to finish all the gardening, all the everything, and squeeze the time and start doing it. So you imagine this is only out of curiosity and only because I feel it is important to explain those kids, not even adults, that they were brainwashed to go on this strike because of the global warming. Unless they're planning to, they better go to school and learn astronomy and mathematics and learn that the temperature increase comes from the large planets. So doesn't matter how long they will sit on this strike, the planets will not move any inch differently.
Nope.
They still will be moving as they should.
Well, it's almost criminal what they're doing, using children for their agenda. They've pushed it to a whole nother level of just disgust in my book.
I don't call it criminal. It is like religion. So they believe in it.
Cult-like.
The religion, and any arguments doesn't reach to them because they believe in it. But what I'm saying, we might not be able to change the minds of all the people, but the young people, they will live through grand minimum. They will live through increase of the temperature. And some of them, the descendant will live to this when the temperature increases strongly. And then they will see it's doable. We can survive it.
But they have to be paying attention. And that's the big thing that we're trying to get people to do, is just to follow it. As complex of an issue it is, pay attention, because there is a huge need for our farmers and people to make these changes, to be able to adapt and move into it. And right now, our farms are underwater, and it's going to be sort of scary over the next few years to see how they adjust.
Yep.
So
some might not even be able to continue anymore as well. So, well, listen, Valentina, it's been a pleasure talking to you. We really appreciate you taking the time with us, answering some of our questions. I think this is going to help a lot of people understand what's going on right now. We do appreciate your time and for you coming on and speaking with us.
Good luck and keep studying.
Absolutely. You're the best teacher we have.
It's beautiful, but it is complex, and don't be afraid of complexity.
That's good advice.
It is easier to put it, step by step, and put all the complexity into components, and it will become very straightforward. Okay?
Great. Very good advice. All right. Thank you once again, Dr. Valentina Zarkova. Thank you.
Thank you.
Bye-bye.
Bye.
Do you like this show? Give us a thumbs up. Want to support us more? Share to your favorite social media platform, buy a t-shirt, or become a Patreon. All links are in the description below.